Hello everyone, my name is Mahammad Neymatov. My major is Bachelor of Science of Computing Engineering. Welcome to the short but exciting journey into the world of calculus. Today we are going to explore how to find the derivative of one of the most mysterious trigonometric functions, y is equal to secant of x. By the end of the video, you will not only know the formula, but also understand why it works and how to use it confidently in the problems. I have added some cool visuals, animations, and examples to keep things fun. So let's jump right in. Before we dive into derivatives, let's make sure we understand what secant of x actually is. Remember the secant of x as the reciprocal of cosine. Secant of x is equal to 1 over cosine x. This means wherever cosine is 0, secant of x is undefined. As you know, cosine is 0 at the point p over 2 and 3p over 2. It means secant of x is undefined at this point and has vertical asymptotes at the points p over 2 and 3p over 2. Here what the graph looks like. Notice how it curves upward and downward and never touches those asymptotes. Now let's get into the calculus. We want to find the derivative of secant of x. Since secant of x is equal to 1 over cosine x, we can use quotient rule or treat it as a chain rule problem. I will use the chain rule here. First, let's rewrite 1 over cosine x as cosine x into the power of minus 1. Now we differentiate both parts using the chain rule. Minus 1 moves forward, the power becomes minus 2, and according to the chain rule, we have to find the derivative of cosine x. The derivative of cosine x is minus sine x, and simplifying, we separate sine x over cosine x multiplied by 1 over cosine x. As you know, sine x over cosine x is tangent x, and as we learned today, 1 over cosine x is secant of x. And here we get the derivative of secant of x is equal to tangent x multiplied by secant of x. Let's plug in some numbers to see how this works. Say x is p over 4. We have to find the derivative of secant of x. As we have already learned this lesson, the derivative of secant of x is tangent x multiplied by secant of x. Instead of x, we substitute p over 4. We find tangent p over 4 second p over 4, and then multiply them in order to find the derivative of secant of x. Let's start writing. Tangent p over 4 is 1. As we have learned in today's lesson, secant p over 4 is 1 over cosine p over 4. Cosine p over 4 is square root of 2 divided by 2. And here we get secant p over 4 is square root of 2. And now the last step, we multiply 1 and square root of 2. And here we get the derivative of secant of p over 4 is square root of 2. That means at x is equal to p over 4, the slope of the secant x graph is approximately 1.41. Now you might be wondering, where would you even use secant of x and the derivative of secant of x? In surveying architecture or satellite positioning, secant theta comes up when calculating distance based on the viewing angles. When this angle changes, the rate of change, the derivative of secant of theta, tells you how fast the distance is increasing. In the right angle triangle, as you know, cosine theta is equal to the ratio of adjacent leg to the hypotenuse. As we learned today, secant theta is equal to 1 over cosine theta. It means secant theta will be the inverse of cosine theta. So secant theta will be the ratio of hypotenuse over adjacent. Let me quickly go over some common mistakes people make with secant of x. Mistake number 1 is mixing up secant of x and cosecant of x. Remember, secant of x is linked with cosine x, cosecant x is linked with sine x. Mistake number 2 is forgetting to use the chain rule when it's secant of f of x instead of secant of x. Remember, always multiply by the derivative of the inside when you take the derivative of secant of f of x. Mistake number 3 is writing the derivative of secant of x as tangent x over cosine x. No, stick with the clean form. Derivative of secant of x is tangent x multiplied by secant of x. To wrap it up, today we learned that secant of x is 1 over cosine x, and the derivative of secant of x is tangent x multiplied by secant of x. We verified it with an example and talked it how it is used in real life. I hope you enjoyed this quick deep dive into calculus. If you have any questions or want more examples, feel free to reach out. Thanks for watching and good luck with your studies.